Good morning, good afternoon, good evening, happy wee hours of the morning whenever you're using this video to help you succeed on test 4. 23, I'm not on 23, I did 23, bad. 25. Okay, now this looks like a strange fraction. When you first look at it, you think, oh my goodness, what are we doing here? But all a fraction is always a division problem, always. So all you're being asked to do here is those two things divided out, that's it. Now this is review from previous units. Here's all I did. 20 divided by 4 is 5. I've got 3 x's here and 1 x here. That leaves me with a couple of x's. And then 24x divided by 4x is 6. We're done. 26. No, not 26, 27. Oh, 27. I need to clear off some space here. Because 27 is pretty involved. 27 is going to ask that we do some long division. Because again, a fraction is only a division problem. But because of x plus 3 is a number, this is a number, and if we start to piece it out like we did before and start to try to do x squared over x plus 3 minus 2x over x plus 3 minus 15 over x plus, that is a hot mess. And it's not going to work very well for this one. So we're going to do some long arithmetic, long division, and I want to review what we even do when we do long division. Let's review that a second. Let's divide 168 divided by 2, just for grins, just to see the algorithm, right? See the process? So that really means this. And now here we go. 2 will not divide into 1, so we just let that slide. But 2 will divide into 16 8 times, and then we multiply, then we subtract. 2 goes into 8 4 times, multiply, subtract, and I'm done. And note that 84 times 2 is absolutely 168. 2 and 84 are the factors for 168, or one pair of the factors for 168. We're going to do the same thing here. Oh, some more space here. But for here, I only need to concern myself with the x. The 3 is just going to tag along. X divides into x squared x times, multiply through. Subtract. X divides into negative 5x, negative 5 times, multiply through. Subtract. And that's it. So that means that this times this had better be that. If it's not, Houston, we have a problem. But it looks like it's going to be good because I got this 0 at the end and everything looks right. But let's go ahead and review that idea anyway, because it is a very important idea in algebra. Remember from before, I'm going to distribute the x, come back and distribute the 3, add like terms, and there we go. Yep. Good job, everybody. 29. Now 29 kind of verbalizes this to divide that by that, and it's kind of mixed up and stuff is missing. So here's what we're going to do. If we're dividing by x plus 3, it's that. It is important that you list your what you're dividing into in descending order. So I'm going to start with x cubed, come back and pick up the x squared. There are no x's listed. That's important. We have to include some x's for a placeholder, but we have to include the number of x's that won't change the value of that number, and then come and pick up the -6. And then we do the same process. X divides into x to the third power x squared times. Multiply through, subtract. See, now we have to have that x so we can keep working. X divides into -2x squared, -2x times, multiply through, subtract. X divides into 6x 6 times, multiply through, subtract. Oh dear, we've got a remainder. That's okay. That's perfectly fine, because this is still this divided by that, and then we just go back to that fraction idea. So your answer is going to have this at the end. Yep. Let's see what 31 is asking us to do. Okay, 31 is asking us to factor, which is just another way of dividing, really. Pardon. It's morning time, and I always have to clear my throat because just a tiny bit of allergies. But it's okay. I hope it's the worst thing that ever happens. Okay. So when you're factoring this way, you're looking for a common factor. And it looks to me like I've got a 5 that I can divide out. I've got x's and y's. This will be the largest number of x's I can divide out. And this will be the largest number, because I don't have 2 y's. I don't have that many, but I do have that many. And now that gives me this piece. And I open up a paren, and I just divide. 5 divided by 5 is 1. X to the 4th divided by x to the 3rd power is x. That's review. Y squared divided by y is y. Then -10 divided by 5 is -2. And then these all divide out to give me my fancy 1. Finished. Feel free to multiply it back through to make sure you get your original problem, 33. Okay, now as soon as you see the parentheses, most algebra learners go, oh goody, I'm going to multiply through. Don't do it. Don't do it on this one, because what you're going to end up doing is making a big circle and ending up right back where we're going to be. What I want you to see is this common factor. I want you to recognize x plus 3 as one number. I don't know what number it is for sure because I don't know what x is. And that provides us a common factor that we can factor out just like we did up here. And there we go. Yeah, because when I divided this out of here, I was left with that one. When I divided the same number out of this expression, I was left with that one. And there they go. 35. All right. Now this looks like nothing I even know how to deal with. There's no like terms, but my instructions are to factor. There's something called the associative property that allows me to group if I need to. Oh, now I can factor because I can divide x squared out of this paren. When I do, I'm left with this. I can divide 4 out of this next bunch of mess. Oh, neat, because look, now I have the same problem that I have up here. There's my common factor. Nice, right? Okay, now 37. Excuse me. So before I start 37, because it's asking you for a cube root, let's talk about what that even means. So let's just start with something that's very familiar. The square root of 4. That's understood as a 2 there. We never write it there. And that's 2. Because 2 times 2 is 4. Right? 2 to that second power is 4. That's all you're doing. Let's figure out, like maybe the square root of 25. Well, that's 5, because 5 squared is 25. But what about a cube root? Let's do the cube root of 8. Well, I know that's 2, because 2 to the third power is 8. Or the cube root of 27. That's 3, because 3 to the third power is 27. That's that idea. But now this problem, 37, you're being asked to take a negative, the cube root of a negative. That's okay. So let's go back and talk about that in terms of this. So if I was asked to take the square root of negative 4, could I still say 2? Because I need a negative in there, and it's got to be the same because of that. So is negative 2 times negative 2 4? No, it's not. So trying to take the square root of a negative, or the fourth root of a negative, let's say the fourth root of negative 16. If it was positive 16, I could say 2, because 2 to the fourth power is 16. But I need to get negative 16. So could I do negative 2 times negative 2 times negative 2 times negative 2? Let's see. That's positive 4. That's another positive 4. No. So this will not work, but it will work for a negative. Let's try taking the cube root of negative 27. I can say that that's negative 3, because negative 3 times negative 3 times negative 3 is negative 9 times 3, which is absolutely negative 27. So it'll work for the odd number, whatever that, I think it's a radicand, I don't know what they call these things. So the cube root of 343 is 7, because 7 times 7 times 7 is 343. Well, the cube root of negative 43 is negative 7, because check it out. Negative 7 times negative 7 times negative 7 is negative 43. Yeah? 39. The square root of z to the fourth. Well, let's do some guessing and checking here. We know we got to have a z in there. Let's see if 2 z's is enough. No, this needs to be to the fourth power. So let's go back and just up the game a little bit. Oh, there we go. Okay, so the square root of z to the fourth power is absolutely z to the second power. So there's your test 4 review. And I'll get this uploaded, send you guys some messages on this and how to finish out our semester strong. Y'all take good care. Bye.